Leslie has class tonight, right? Leslie and Rochelle? 171? Okay. Is anyone still working on the check-in? Okay. Perfect. I think it closes at 2:25. It'll just automatically shut you out. Okay, cool. Let's see what time it is. 2:25. Okay. Anyone still working on the check-in? It'll shut you down in a minute. Okay, so that's a check-in. So most days, maybe not every day, but most days there'll be a check-in, and it'll be related to whatever the assignment was. So on Wednesday, the check-in will be about Module 4, okay, which is the physical layer, media, okay? And so we'll be doing that. Some days we'll do check-outs. You know, if we have time today, we'll do a check-out. And the check-outs will be about whatever we talked about, or again, just reconfirming and refreshing on whatever we talked about. For the most part, again, we're never trying to trick you. I'm just trying to keep your brain on this stuff over and over and over, right? And making your brain see things in a different way, think about things in a different way. And with your note taking, sometimes, especially in the beginning, did any of you experience this where as you're maybe reading or watching a PowerPoint or looking at the PowerPoint, it seems like everything's important, right? It's like, well, this seems important, that seems important. And it takes a little bit of time for you and the stuff you're doing to figure out like really what is important so that you can start to parse that down, right? That just comes with practice and with time. And some of you did a really great job on your notes. I especially saw a couple of people who I could tell where they would ask themselves a question or maybe even write the question that we had in there and then answer that in their own words. Right? And so I think that's a really effective way to learn versus, again, just rewriting exactly what you're reading. So if you can practice that, it'll help you a lot. If you stay in the field of IT, you're going to always have to be learning. Chances are you'll frequently be taking certification exams of some sort, right? So that's one of the reasons, too, why we just do a lot of quick quizzes, just to keep you in that mode of being able to think on your feet, answer questions, start to narrow things down through a process of elimination, answer things fast, just all of that. It's just a constant practice, okay, and keeping yourself on it. If you are not logged into the VM, why don't you go ahead and log into the VM? I don't know that we'll need it today, but just to get into the habit of doing that. And just as a reminder, if you find the icon here for Cisco Lab and double click on that, and let me just remind you how to get it so that your thumb drive will work in here. Oh, why didn't it give me my choices? Oh, okay, I'm like Oh, here we go. So what we would want to do, right, I don't have two monitors, so I'm not going to do that. But if we do show options and you go to local resources, okay, so we're in display, we want to go to local resources and click more. And then just click the drivers and the other supported plug and play. Next week for sure, and maybe Wednesday, but next week for sure we'll be in the VMs because we're going to start doing labs next week, and you have to be in the VM. And it will be super helpful if you have your thumb drive because you're going to want to save your labs and you'll be answering questions on your console device. And so we just want to make sure that we're in the habit of going in there. And then we're going to hit OK. And remember what the password is? Class. All right. Oops. Wrong one. There we go. Okay. I want everyone to go and I want you to check your grades. So if you just go to grades, I want everyone in the habit of looking at your grades. There's nothing worse than in the 8th week, someone comes to me and says, Andrea, I have an F. And I'm like, well, haven't you been checking your grades? They're like, no, I've never looked at my grades. So just get in the habit of looking at your grades. And the other thing I want you to be in the habit of is reading our comments. Now, for the most part, these first few weeks, most of our comments are, good job, thank you for turning in the assignment. And that's because I want you to see those comments. But when you start doing labs, we're going to be possibly putting more in-depth comments in there. So I want you in the habit of going into the assignment and actually looking at those comments, which I'll show you how to do probably on Wednesday. So if we look right here, whenever you have the text bubble, that means that you've got a comment, right? Thank you for completing the assignment. So if you would all just take a minute and look at your grades and then run through any comments, right? And just check to see what we're putting on there. So take a couple minutes and look at any comments. If you want to look at the rubric, you can look at the rubric, right? And it will tell you what the score is. And if you have a lower score, you could look at the rubric and see why. It might say, oh, you're missing some elements. And it will even say you're missing some elements, just resubmit it, right? As long as the assignment's open, you can always resubmit it. Okay, and again, most all assignments are open till the last day of class, except class activities. We'll do a lot of class activities in here. You have to be in class to do those. You cannot be out of class. You can't make them up. They're in-class activities. Okay. Everybody good? Everyone check their grade? We should all be doing pretty good so far, right? Doing pretty good right now. Grades, comments, okay. Excellent. And thank you. I think everybody watched the videos, which I'm very excited about. All right. What do we want to do first? We want to count by binary first. Has everyone been practicing? 1, 2, 4, 8, 16, 32, 64? 128. Okay, ready? So again, we're going to go all the way up to 65, 534. If you have your little sheet to help you, you can use that. And we'll do it on the down. And I'll help when we start to get to the bigger numbers. All right? So everyone be calling out. Does everyone have whatever sheet they need? Okay, 1, 2, 3.
1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 426,
8192, 16384, 32768. Good job. I think I have a couple people that will get some extra credit, but you got to do it as fast as me by the end of the semester. Okay, can you take out a piece of paper and write it straight down? Even if you already have it, write it again. 1, 2, 4, 8, 16, 32. Write it, take a clean sheet of paper, write it straight down, because we're going to add something to this list. If not, I've got something. The punishment pencil. Does anyone need something to write with? Okay, so straight down, because we're going to add something. 1, 2, 4, 8, 16, 30. Rewrite it even if you already have it. Rewrite it even if you already have it. So when you take the Cisco Certified Network Associate Certification exam, they're going to give you a 9x12 dry erase board, and you can put some notes on there before you start the exam. And this is one of the things that you're going to want to put on there. 1, 2, 4, 8, 16, 32, 64, 128. Do you need something to write with? No. Okay. Paul, do you need something to write with? Okay. Did you already write it? Perfect. Thank you. Awesome. Did you write it? Yep. Where at? Okay, that'll work. Let's write it straight down. So remember, some of what we're going to do all this week regarding numbering is getting ready for what we're going to do next week and the week after. So it won't all, you'll be like, why are we doing this? It'll start to make sense then. But we got to kind of pull the little pieces together before we put the whole cake together. Everyone got it? Okay. Keep going. 65, 534. Or 536, whatever that last number is. So 2 octets worth. 2 full octets worth. Okay, so we're going to add something to it. How many bits are in an IPv4 address? 32. Okay. How many octets are in an IPv4 address? How many bits are in an octet? How many bytes are in an octet? 1. Okay, so here's what we're going to do. We're going to add a little something to this, okay? So we're going to add a /32 and then a /31. And we're just going to count backwards, starting with 32. 32, 31, 30. Just add that to each of these. Make sure you don't miss one. It's like if I go too fast, invariably I always miss the 29, and then it messes everything up. 32, so I recheck my work. It's taken me many mistakes and years of breaking things to learn how to constantly check my work. Okay, I think I got it. So everyone got it? Okay. And then after the 8th, 1, 2, 3, 4, 5, 6, 7, 8, just draw a line right here. After the 128, just draw a line. Okay. Now, this will represent the 4th octet of our IPv4 address. So just add that. Okay. So which one does this one represent? 6, 7, 8. So let's just draw a line. This one represents the third. And this one is the second, but we're not going to keep going. Those numbers get too big for me to do without a calculator. And remember, to count by binary, we just doubled, right? So if you don't have a calculator, because you won't have a calculator whenever you're taking any type of certification exams, there is no shame in just writing it out, right? I mean, I had to memorize stuff because I was always like, okay, well, 81, 92, 81, 92, okay, that's 4, okay. That's fine, just, do it by hand. If you're taking a certification exam, you're not going to have a calculator, and if you need to do a little math, don't try to do it in your head, right? That's when mistakes happen, when you're under pressure, you're on a timeline. Just write it out, there's nothing wrong with that, just write it out. All right, so we're good with this, right? Excellent. And everyone watch the videos. So we're going to go through the binary to decimal. We're going to review that, and we'll review a little Boolean too. So the next thing I also want you to do is to create yourself a positional value chart. So what were the positional values? Who could give me the positional values of an octet? Yeah, let's hear it.
So 8, 128, 64 is 7, 32 is the 6th, 16 is the 5th, 8 is the 4th, 4 is the 3rd, 2 is the 2nd, and then 1 is the 1st.
Exactly. And if we go the other way, 1, 2, 4, 8, 16, 32, 64, 128. So again, let's everyone give yourself a positional value chart. It's going to make your life easier. And if you already have one, my preference is that you make a new one. Just keep practicing over and over and over. 30, 16, 8, 4. I'm messing up. 2, 1. Okay, so make yourself a nice positional value chart. It's going to come in handy. Yes? So it's going to go 1, 2, 4, 8, 16, 32. And just someone tell me what I said about the octets and the positional values. What do they do? Check your notes, because I told everyone to write it down. Yes, the positional values repeat in every octet, right? So the way that this would work is it would look like this. I'd have 4 of these. Because I have 4 octets in a what kind of address? IPv4 address. So I've got 4. This is the first octet. This is the second octet. This is the third octet. And this is the fourth octet. And these repeat. 1, 2, 4, 8, 16, 128. 1, 2, 4, 8, 16, 32, 64, 128, right? Okay. All right, so the ones represent what in my computer world? On. And an off is represented with a 0. And that's all we do to figure out our binary, right? Because each of these have a value. And so, and then we also learned Boolean, right? We learned how to look at our Boolean, and we did that first because we just needed to understand 1s and 0s. And then we're going to add binary to decimal on it. All right, so let's do this one together. Everyone, a 1 and a 1, a 0 and a 1, a 1 and a 1, a 1 and a 1, a 1 and a 0, a 1 and a 0, a 1 and a 0, and a 1 and a 1. Okay, so now can we also figure out what the value is of this? We can, right? So in this scenario, right, here's my outcome or my value. So the 0, this is off. So what does that mean about the 128? Right, it's not going to be part of my total, right? So this would be a 0. And what about this one? The 64, is it on or off? Yep, it's off. My 32? Yeah, that's on. So I'm going to have this as part of my value. 16, I'm going to have that as part of my value. And the 8, the 4, the 2, all right, these are off, off, off. How about this last one? 1. So now I can do the math. 32 plus 16 plus 1, 49, right? So that's not bad, right? It's not bad at all. Okay, so we've already counted by binary, right? 1, 2, 4, 8, 16, 32, 64, 128, right? We got that. We've added, these are subnet masks. And again, we're going to talk about that a little bit later. So these represent subnet masks. Okay. And how many octets in an IPv4 address? How many bits? 32. Hey, Chris, could you get me some cleaner? It's in the cabinet. Okay. So let's see here. This is octet. Exactly. Okay. So that's 1, 2, 3, and 4. Okay, we've answered that. And this is everything then converted to binary. So today we're going to work on binary to decimal and decimal to binary. Thank you. And then there's some that I want you to memorize because it will make everything else easier. Okay, it'll make everything else easier. All right, let's do the positional values. 1, everyone?
2, 4, 8, 16, 32, 64, 128.
And what do? They repeat in every octet, right? It doesn't matter if I'm talking about octet 1, octet 2, octet 3, octet 4. So the math that we do for each octet is exactly the same. Okay, that's what's important about that. The math that we do is important for each octet. Okay, so if I have this binary 11000001, what would the value be? Go ahead and do the math. Okay, louder. 193, right? Because the 128 is turned on. The 64, is it on or off? It's on, right? So now I'm at 192. Everything else is, and the 1 is on, so 193. So here's a little trick to keep in mind. Whenever this last position is on, what kind of value will we have? An odd value, right? Because we're just dealing with two numbers. 0 and 1, so if you have to add a 1, you're always going to have that odd number. If the positional value of 1 is off, you'll always have an even number. Okay, so then we just do the simple math, right? So I say don't try to do it in your head. Eventually your brain will just remember it. You'll be like, oh, 128 and 64, that's 192. 1010, that's 160. 1010, 101010, that's 170. You'll just know, okay? Let's see, how do we convert from binary to decimal? So we already did it. So let's go ahead and let's do this one. Just write down the value. Write down the value. Don't call it out yet. Just write it down. Okay, got it? Got it? Okay, so we're going to add 128 plus 8421. Now, something to keep in mind is 8 plus 4 plus 2 plus 1. What does that add up to? 15, right? So if you know that these last four values add up to 15 and you see those on, it starts to make the math a little easier. I could just say, oh, 128 plus 15 versus 128 plus 8 plus 4 plus 2 plus 1, right? So little patterns here, right? So what is our total value? Okay, 128, 8421, right? 143. When everything's on, what have we got? 255, right? So one thing we could do here, so what if I see everything is on except the first position? 254, right? What if I see everything is on except the 16? I can just take 255 minus 16, right? So sometimes it's easier if you have one value off to do a little subtraction, even if you have to write it out, right? 255 minus 16 or 255 minus 8. So there's little tricks that will make things faster. 255. Okay, so these are the ones that I want you to kind of see the pattern and start to memorize, and I'll show you why. Okay, so if the first four are on, what have I got? So do the math. 240. Okay, so if the first four are on, and I just have memorized, oh, that's 240, and then I turn the 1 on, what have I got? Okay, the first four are on, and then the 8 is on, what have I got? Okay, the first four are on, and the 4 is on, what have I got? 244. So I want you to memorize, okay, when I see the first four on, that's 240, because that starts to make seeing a pattern easier. Okay, now we've already said what the last four are, so what are the last four? 15. Okay, so remember the first four are 240. If you only see the last four, that's 15, and then use that to make the rest of the math easier. Okay, all right, so here's another good one to remember. 1, 0, 1, 0, and everything else is off. So what would that one be? 160. So if you see 1, 0, 1, 0, and the 1 is on, what have you got? Right? If you see 1, 0, 1, 0, and the 4 is on, what have you got? If you see 1, 0, 1, 0, and the 8 is on, what have you got? Okay, so if you can get that pattern, doing binary to decimal and decimal to binary starts to get quicker. Okay, here's the next one. So what about this one? 10. 10. Okay, so if you see a 0, 0, 0, 0, 1, 0, 1, 0, we've got a 10. So now what if the 128 is on and we have 10? What have I got? What have I got? 138. Okay, what if I have the 16 and the 10? 26. So you see how that starts to make that go faster. So I want you to memorize those. Okay, so now when I put it all together, 1, 0, 1, 0, 1, 0, 1, 0, I have 170. Make sense? Okay. Let's see. So how about this one? So we did 1, 0, 1, 0. Now we're doing 0, 1, 0, 1. 80. So I have 80 and I turn on the 4, I have 80 and I turn on the 4 and the 1 and I have, see the trick? Okay. What about this one? We already did it. 10. So now if I have the 80 and I have the 10, I have 90. Okay? All right, so let's do this. Going to hand this out. I want you to fill in the positional values at the top, okay? And then you're going to just take the value, fill it out, and then put the outcome, okay? And it's just all the ones we did plus a few others, all right? Aiden, can you help me pass this out? Everyone get one? Everyone have something to write with? When you're done with them all, just pop your hand up so I can come walk around and take a look. Okay. Fill those out. So this is turned, you're taking this value and you're putting that there. So you're filling this out with the, either way, you can either do the 1 or you can do the value, whatever makes it easier for you. So whatever makes it easier for you. So this is the value that we're working with, right? So you could do it like this. Okay, or you could do it with the value. So here, this first one is on, so I could do 128, right? 0, 0. So whatever makes this easiest for you to visualize, or this one, so the 128 is on. The 64 is off, the 32. So whichever is easiest for you, right? If you already have a pretty good grasp of binary, just do the 1s and 0s. If you're still working on adding them up and figuring them out, put the values in. So whatever works the best for you. This is going to be something that you keep. If you finish that side, you can work on the next side. But I really just want us to finish that first front part. There's always one in the class. Yeah, I know. I got your number, Todd. It's a good thing. So when you're doing this, look at the patterns, right? Don't just rotely go through things. Look at the patterns so that, you know, when we do this again, it's going to get faster. 1010 is 160. 0101 is 80. Done, Taryn? Okay. Did you do the other side? Go ahead and do the other side. If you finish, do the other side. If you finish the front, work on the back. So you see there's a couple more up here that we didn't do, right? This 0, 1, 1, 0, what's that?
What?
96, right? The 0, 1, 1, 0 is 96. So then if you add 4 to it, 100. See why that one's kind of handy to remember? What about, let's see, is there, oh, I don't see that one on there. Come back to it later. All right. So if you're still working on that first side, just pop your hand up so I see where we're at. Couple people, okay. Okay, so for those of you that are done, I just published another one just to practice. Okay, it's under week 2's class activities. Refresh your screen, and you'll see it's a brain teaser. Okay.
So brain teasers are in class?
Not all of them.
Not all of
If
them?
they say class activity, it's in class.
Okay,
So
okay.
there it is, right there.
Okay.
Okay.
So that's how I would identify whether it's something I would do on my own or something.
Right.
This is classic.
Yep.
Okay.
Yep. All right. What is happening? All right. Okay, so wherever you're at, just stop for a second. Let's do this quick Kahoot. Then we'll come back to that one. So we're going to do a Kahoot. So let's just see how fast you can do it, right? Just without, use your positional value chart if you need to. Remember, this isn't hurt anything. This is just for participation. So let's just see how we can get through this, okay? You go to kahoot.it, or you can use the app. This one's going to be quick and easy, right? So this one will be quick and easy. Won't be too many where you have to add them up, right? So just go to kahoot.it. Who am I missing? Did I count wrong? 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have 11 people in there. Ah, there you are. All right, so again, give yourself enough time to answer correctly, but just see how quick you can get it. Just have fun with it, okay? Again, this one should be pretty easy because it's a 1 star. So 1 stars are the easiest. Nice. Odd or even? Odd. Not too bad, right? You see your brain's already recognizing the positional values? 10 out of 10. Awesome. Good job. Good. Yowza. Awesome job. I like it. Okay, let's do another one. Let's see. We just did that one. Let's do... Ooh, 3 stars? Let's do another easy one. So same thing, just a different batch of numbers. Ready? So the first 4 are 240, and you just got to do the math after that. Excellent. So if we did this one the fast way, right, if we know that the first 4 turned on are what, everybody? 240, and then I've got the 8 on, so that gives me, and then I need to add 4, right? So if you can remember that these first 4 are 240, that makes the rest of the addition easier. And that's how a lot of these are going to be. They're going to be using those patterns that we put on the paper. So keep that paper handy so you can see your patterns, okay? When they're all turned on, they're a what? So then you just subtract 1. It's one of the patterns. Yep, the 1010, everyone? 160. So it's one of the patterns on our table. So again, with this one, if you can memorize that when those 3 are on, you have 224. And then if you just add 4 to it, what have you got? 228. And if you have 224 and you add 1, 225, right? So that's why remembering those key ones will make the rest of it go faster and easier. The first 4 are on, so what have we got? Plus. Okay. Ten out of 10, 10, good job. Outstanding. Excellent, good job. So again, this is just one of those things where you just have to keep practicing and practicing. So give me just a second. I'm going to have us just enter in that we did these in class. So I'm going to have you put this one that we did it in class. You don't have to turn anything in, you'll just note that text entry that we did it in class. That way I can give you a completion on it. And you'll see the little line on your calendar. And that's the worksheet that we did. So it's going to be, again, we're in week 2's class activities Monday. We did 2 Kahoots, so I'm going to due date these 2. Just same thing, just put in there that we did it in class. It's missing. Oh, okay, that's okay. At noon today, I don't know why it would be noon today. Oh, look at that. See, it just automatically goes there. It's supposed to go to PM automatically. I don't know why it does that. Here, I'll do that. I'll go fix this one. There must be a setting in here that I need to figure out. I'm going to fix it right now. Did this one do the same thing? Yep. PM. Okay. All right. So we did those 3. Again, just put a note in the text box that we completed them in class. Go ahead and finish this brain teaser, and then let's take a break. So it is 3:19. Let's come back at 3:28. So finish the brain teaser. If you need to get a drink, go to the restroom. We'll pick back up at 3:28. Actually, let's just do 3:30. That'll give you plenty of time to do that brain teaser. So that means we will have done 4 assignments in class together. The worksheet, 2 Kahoots, and the brain teaser, okay? If you have any questions on them, just let me know. Probably have to refresh your screen to see the published version, because I just now published them, so you won't see them unless you refresh your screen. Yeah, we did Kahoot, convert binary to decimal. We did 2 of them. Oh, 3 p.m. What time is it? Oh, it's after 3. Oh, boy. Which one says 3? This one. Okay, let me fix it. Refresh it and try it again.
supposed to like submit something for the Kahoots?
Yeah, just put in there that we did it in class on the text entry. Can you refresh your screen?
I'll even go.
Is anyone else having that trouble?
Oh, there you go. Second one works.
The first one says due by Monday, 5 p.m., but it's still on.
Ay, ay, ay. Hold on, I think it's the wrong one. All right, so let me close these. Let's see. So the worksheet is working, right? Okay, so the worksheet's working. Now what about convert binary to decimal with the one little star? That's the one you're having trouble with. Okay, hold on. Good grief. Let's see.
I know.
No submission, that's why. Okay. Ugh. Refresh your screen and try it again.
Is this like a primary example of things you'll often find in IT?
Yes. A person who doesn't know how to turn things off or on.
No, it's human error. You can go basic.
So again, just finish up that brain teaser, take a break, and then we'll hit it again. All right, so we're going to talk about Module 3, protocols and models. I would recommend that you have something out to take notes. Also have your notes ready, so if if I ask a question and you're like, oh wait, I know that, it's in my notes. All right. So one of the questions in the learning resources is, what are the 3 fundamental requirements common to the communication method? So who has the answer for that? What is it, Tim?
Message source, message destination, and channel.
Exactly, right? So it's not overly difficult. And I'm going to probably kind of use like an example of an email often, right? I'm at my desk. I have my email application opened up, which that's the source, Google email, right? And I'm trying to send Paul an email in Pennsylvania, right? So I'm the source, right? I'm trying to get to a destination, and something has to carry that information from source to destination. That's just the basics of any communication. I order a pizza, right? Domino's makes it. The delivery person takes it to me, the channel, and they deliver it, right? So nothing overly complicated for that. Now, the stuff, so we've got the source, which might be my computer, my application. Then we've got the channel. So in our world, we're going to call that channel the media. Okay? Now there's a bunch of stuff that goes on in between there, but the media. And media is referring to the Ethernet cable, radio frequency, the fiber optic. It's what's carrying the data. Okay? Now this whole module is pretty much about the OSI model and the TCP/IP model, the protocol suite. And all a protocol suite is kind of like a recipe. It's a way to describe the way that data moves through the network. Okay? It's a way to describe the way that data moves through the network. So if I were making a pizza, right, I start out with the dough. Yes?
What's the difference between your protocol suite and like your maybe languages or something like that? How can I frame it?
Well, I'm not sure that they're really even related, although your languages are going to fall in there amongst the suite. So for example, the reason we have a protocol suite is so that we have standards and we meet certain criteria. Many of you, so who has like an Android cell phone? Okay, and then who has like the Apple phone? Okay, so for those of us that have an Android, we all have the same type of plug-in to charge our phones, right? And if you have an Apple, you have the same as all the other Apples, okay? Well, protocol suite is what dictates that, right? Because they came along and said, listen, so I don't know, maybe you remember, but I remember back in the day when every time you would buy a phone, it would have a different charger. Is that in your day, Todd, your day? Right? And so the organization came through and said, wait a minute, you're basically screwing over the consumer here and you need to stop it. So what protocol suites do is they dictate certain criteria that have to be met at each layer of the OSI model so that that doesn't happen, right? Same goes with languages, right? There's like a number sign means this in this language. You know, the open quotes means this. So there's standards that are set up, and that's what the OSI model will do and the TCP/IP model. Okay? So in the OSI model, there's 7 layers, and something different happens at each layer. So again, if I'm writing out this email, that's at layer 7, 6, and 5. So I'm typing out an email. And then as I hit send, it's going to move down the OSI model or the TCP/IP model, and I'll explain that in a minute. It's going to hit layer 1, the physical layer. And the physical layer is where this NIC card is and the cable, or if it's radio frequency. It's going to move across the channel / media, right? And then it's going to hit the other side. So now it's closer to Paul. And then it's going to start moving up the model to where it's at the application layer again, where now he can open it up and read the email. Okay, so again, all the OSI and TCP/IP model does is explain how that data moves through, just like if I were making a pizza. So there's the meat lovers pizza, there's the veggie pizza, right? I'm starting with the dough, okay? I start with the data, okay? Now, the TCP/IP model is exactly the same thing as the OSI model in functionality, okay? In functionality. Both of them just describe the way the data moves down and over from source to destination. They both describe that. The difference is the TCP/IP model is just the legacy version of it. Back in 1976, when the internet came, there was very little we could do with the internet compared to now. As an example, I could send emails in 1980. However, I couldn't attach an MP3 to it. I couldn't put a PNG on it. I couldn't encrypt it. I couldn't put it in a zip. I couldn't do anything like that, okay? And so the TCP/IP model has how many layers? 4. So 4 layers used to do the job. 4 layers used to do the job in order to describe, well, you're going to pack up this stuff, you're going to move it down the model, it's going to hit an Ethernet cable, which was probably an analog cable back then, right? It's going to hit the cable, it's going to move over. And it was only in government agencies. So you'd go from one government agency to another government agency. There was no such thing as a person having an email at home, right? Well, as things began to expand, the application layer of the TCP/IP model no longer did a good enough job to do a breakdown of what happens at that layer, the application layer of the TCP/IP model. So they're like, well, we need to add a few things, right? So if I have the TCP/IP model, which was, we're going to call that kind of like legacy, right? And you'll still hear people all the time refer to the TCP/IP model or the OSI model, because remember, they do the same thing, right? It's just that one isn't as granular. It's just not as granular. If I compare that to the OSI model, so what's the 4 layers? Let's start with the application. So the topmost layer for the TCP/IP. What's the next layer? So application, transport, internet, and then the next one, network. Now you have to watch the terminology here because what's one thing here is something different there. Okay, so that's my TCP/IP. All right, so now what about the OSI model? What's that topmost layer? Application. Next, presentation. Session. Transport. Network. And the last one, physical. Okay, so if we break these down, so it now takes these 3 layers to describe the application. So again, if I'm going to send an email, that's happening at the application layer, and maybe I'm going to attach a PNG file to it. And if a PNG file is attached to it, that's taking advantage and using what's happening at the presentation layer. It's something that's being presented. If it's an MP3, if it's an MP4, something that's being presented. Also, if I need to encrypt something, which will change the way it looks, if I have to compress it, all of that's happening in these layers, application and presentation, okay? And then here, the transport is the transport layer. So they're doing the exact same thing in this scenario, okay? Now, in the TCP/IP model, we call it the inter-network. So I think of it as the inter-network layer. And the reason I do that is because then it helps me remember that it matches up to the network layer of the OSI model. Okay, got that? And then lastly, the network layer. That's our data link layer and our physical layer on our OSI model. Okay, so again, they're doing the same thing. It's just that as we began to advance and we added different services and protocols, we needed a more clear way, a more granular way to describe how the data moves through the network. Okay? So we're going to talk about all of this. So let's start with encapsulation. So who can tell me what encapsulation is?
The data moving down each layer and kind of changing a different form as it goes through each layer.
Exactly. Jonah, do you have anything to add? Yeah, so it's moving down and it picks up information. So I'm going to describe this in a more clear way. And every time it moves down the layer or up the layer, it's called something different. Okay? So I'm going to explain. Let me get a drink. So again, let's start out with this email. Okay? And at the email, I've typed out the email. Let's say I've got a big long email, maybe I've attached a photo, whatever to it, right? So that is called data. Okay, this is called data. Because we also have to think about protocol data units. All right, protocol data units. And that is the form that it takes as it moves down the layer. So I've got this data, and it's got, I'm at the application layer, I'm at the Google Gmail, right? I've added my picture to it. Now, because I'm going to send it someplace, I have to open up a session. I have to establish a session, which is basically letting the internet world know that something's going to be coming and moving through the network, okay? So a session gets opened up. So at this layer, 7, 6, and 5, all of this is just called the data, okay? Now, it's got to get pushed down to the transport layer. The transport layer is when real networking starts, when we actually start packaging this data in a way that it can be moved from me to Pennsylvania. In order to do that, it needs additional information. Okay, so again, I'm making a pizza. So I've got the pizza, I add some cheese to it, right? So that's encapsulating it. That's encapsulating it. So it's moved from data down to the transport layer, and it picks up information at the transport layer. What's it picking up?
Like the protocols for that layer?
Yeah, it's picking up the protocols for that layer, and specifically, it's also picking up port numbers. Write that down, okay? It's picking up port numbers. Every source has a port, and every destination has a port. So if I needed to drive from my house to Darren's house, right, I've got to have some information. So that process of picking up information is called encapsulation. So it just got encapsulated with some information, and specifically at the transport layer, the port numbers, and some other protocol information. Yes?
So at the transport layer, they're picking up source and destination.
It's
Address.
ports, port numbers, just port numbers. So I'm going to show you something here. So this is what my device is doing, okay? So here's my IP address, and this is actually a port number. So I have an HTTP session established, okay? And that's my source port. What's the port for HTTPS? 443. Is it 443 or 440? 443, okay? So it's got a source and a destination port. Now this could have 443 right there. Instead it just has HTTPS, okay? So I've got my data. It moved down to the transport layer. It picked up a port number. And that's so when stuff moves back and forth, it knows where to deliver it on my PC. Okay, so it's encapsulated the port number. Now there's other stuff that happens at the transport layer. Okay, segmentation happens. Write that down. Unless you know it, write it down. What else happens at the transport layer? So I've picked up a port number. I've segmented the data, which means I've chopped it up. I've chopped it up. So what else is going to happen right there? It doesn't encode until layer 1. Yeah, so it's going to give it a tracking number so that it can be reassembled. So it's going to assign a tracking number, so it gets chopped up. So think about this great big long email that I've sent with a picture. I'm sending to Pennsylvania, okay? Now, we already know how does it move through the network. Does it move through as ones and zeros, or does it say, Dear John, blah, 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 ones and zeros, right? So imagine I've sent this great big huge long email with a PNG and maybe an MP4. It's giant. It cannot go through the network as one long worm, right? So it gets chopped up. It gets chopped up, and it goes in all different directions. And each piece gets a number. So it's got a tracking number, 1, 2, 3, 4, 5, 6, 7, 8, 9, so that when it gets to Pennsylvania, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now it also gets multiplexed. Okay, so what's happening is it picks up port numbers, gets segmented, multiplexing happens at the transport layer. Okay, so who can tell me what multiplexing is? Raise your hand. I saw it in people's notes, so I know that someone knows. What's that? Okay, multiplexing helps efficiency and speed. Yeah, so let's explain what that means. So you said sending multiple messages at the same time, right? Did you say something else too? On the same line. Okay, so let's go back to my command prompt. Now, how many sessions do I have established? A lot, right? A lot. So my computer, I've got my browser up, I've got Neticat opened, maybe I'm running a video, I've connected to Netflix, I'm in Canvas, I've got a PowerPoint up, like I've got a lot happening, right? So that's what you just said. It's that I can have a lot happening. So the transport layer keeps track of all of these conversations. And it's doing that with the port number. So if you look at this, like each conversation that's established, it has a port number. That's how it's keeping track. So that's called multiplexing, where I can have several conversations happening at one time. Now again, back in the old days, you could only do one thing. You could send an email, and you'd close that, and then maybe you'd, look at a website if there was such a thing. I used to go to a chat room. I could only go to the chat room. I would play some game called Arachnophobia. That's all I could do. I couldn't have an email and play Arachnophobia, right? But through the transport layer, I can do multiplexing. Okay, so the transport layer, we've encapsulated it. Now, at the transport layer, what do I call this piece of data? So remember, I started out with data. I moved it down to the transport layer. I got encapsulated where I picked up what? Port numbers. I got segmented, multiplexed, and I picked up port numbers. Now this data, now that it's been moved down, it's called something different. What do I call it at this layer? It's a protocol data unit. What is the protocol data unit called at this layer? Yes, the segment. It gives us a little clue, right? They call it the segment because things get segmented. Kind of like a pizza. Let's use the pizza example, right? So first I just have a cheese pizza, but then when I add pepperoni to it, is it still a pizza? Yes, but now what kind of a pizza is it? Pepperoni pizza, same thing, right? The email was data. I've pushed the data down, I've wrapped it up so it picks up port numbers, and now it's called, everybody, a segment. It's called a segment. Okay, everyone got that? Okay, so I'm at the transport layer. I'm going to get pushed down to what layer? The network layer. And what happens at the network layer? Right, and what's that process called, Darren?
Where it picks, encapsulation.
It's called encapsulation. So it gets encapsulated again. So the segment gets pushed down to the network layer and it gets everybody encapsulated. Okay? The term encapsulation just means it's wrapped up, picks up more information. Okay? So what is it picking up now, Todd? What does it pick up here?
Don't know.
Jonah. Network layer. What's it pick up, Aiden? IP addresses. Source and destination IP addresses. So remember, this process of moving through the OSI model is so that I can go from the source to the destination. Well, to do that, this data needs information. It needs to know what port numbers are associated with the source and destination. It needs to know what the IP addresses are of the source and destination. So at this layer, the network layer, it gets encapsulated. It's going to add its source and wherever I'm trying to go. I'm trying to get to Pennsylvania, whatever that IP address is, right? Just like if I'm mailing a letter to Pennsylvania, I'm like, 123 Rockville Street, Philadelphia, right? And then I put my return address on it. That's my source. Put it in the mailbox. Mailman picks it up, drives it. That's the media. Takes it to the destination. Okay? So every time it's moving, it goes through the process of what? Encapsulation. Encapsulation. All right, so I'm at the network layer. Now that I have, it's still, the data is still in there, right? And the PDU for the segment, it's still in there. But now it's been wrapped up with the source and destination IP address. Okay, now I've got to push it down again to what layer? Data link layer. Okay, now what happens here? Before that, what's the process called? Gets encapsulated. Okay, and what does it pick up? Right, the source and the destination MAC address, okay? So at layer 3, the network layer, this is what allows it to move to a remote destination. The network layer allows it to move to a remote destination. I don't see people writing. Is that because you all know this?
Source and destination MAC address?
Yep, at the data link layer. So the data link layer works at layer 2. So if the network layer is remote, what's the data link layer? Which is? Local. So from Jonah to Oscar, from Oscar to Blake, from Blake to Alan, from Alan to Paul. Local. Okay, so the MAC addresses is what allows this PC to talk to this PC. These two PCs, they don't need IP addresses to work if they're only talking to each other. They just need MAC addresses. Okay. And does every device have a MAC address? Yes. Yes. Okay. All right, so I went from the network layer where I was called a what? What was the PDU called at the network layer? A packet. A packet, an IP packet. So now the packet gets pushed down to the data link layer where it gets what, everybody? Encapsulated. It picks up the source and destination AIDN, MAC addresses. Okay. So what's it called now? The frame. It's called a frame. Okay. Now there's a bunch of stuff inside the frame. Source and destination MAC address, but there's other stuff. There's like a timing mechanism, a control mechanism. There's some other stuff in there. An error detecting, which we're going to learn about in module 6 and 7 and 9. So there's a bunch of stuff in the frame. Mm-hmm. Yeah. All of this is the header. So there's an IP header. There's a data link header. Okay. All right, so we're good how this is moving, right? Everyone's good there? All right, so now we go from layer 2, the data link layer, down to the physical layer. Now this is actually, there is no more encapsulating. It's the frame, right? It's the frame. So what happens is we're going to get pushed down to the physical layer, which is essentially on our computer like where the NIC card is. Right, and that connects to our Ethernet cable or a fiber optic cable, radio frequency, whatever it is that we're using. Okay, so radio frequency uses radio frequency, right? So like waves. Ethernet, what does it use? Copper wiring, which would be electricity, yeah, on, off, on, off. Fiber optic, light, on, off. Okay. Computers, switches, routers talk in what? In binary. In binary. So encoding is another one of the terms up here that you've got to know. So was it you that gave me the definition of encoding? Who gave me the definition of encoding?
I think I gave you encapsulation.
Okay, somebody gave me encoding. Okay, so who can give me the definition of encoding? Yes, the data in an acceptable format so it can move, okay? Because the NIC card is delivering ones and zeros, but fiber optic talks in light, right? On and off, on and off. So encoding or decoding is just the process of taking that data and putting it into a form that can move across the media regardless of whether it is, whether it's wireless technology, a fiber optic cable, an Ethernet cable, okay? So we just moved all the way down the OSI model, or it's the exact same process in the TCP/IP model, it's just that it's not as granular. The information gets encoded into Ethernet, on and off, on and off, on and off. It moves, it moves, it moves, it moves. It comes over to what layer at the destination? Physical layer. And now it gets what? Before that. Somebody said it. Decoded. It's got to go back to the bits. It's got to go back to bits. Okay, now I have to start peeling information off, and that's called de-encapsulation. De-encapsulation, right? So I'm at the data link layer, and data link layer functions where? Local area network. So again, let's say Jonah is trying to talk to Aiden, and so Aiden's going to talk to Jonah. So what has to happen is it de-encapsulates it, and it's like, who is this meant for? What's the destination MAC address? So it's de-encapsulating it. And then it gets pushed up to what layer? Okay, and then what happens to it? And it's looking at the source and destination IP address, and then it gets pushed up to the, right? Where it's got what? Port numbers, yes?
So if it actually already has the MAC address, what's the point of having the IP address as well?
If I'm trying to get to a remote location, I need an IP address. But locally, we don't need an IP address. Just within this room, we have them, but we actually don't need them to talk to each other. Okay, we actually don't need them to talk to each other. We just need a local address. So a MAC address can be called a lot of different things. What's something else it would be called? Hardware address, yes, what else? What? Logical? Not a logical. That would be our IP address. So a MAC address, a hardware address. A what? Yeah, I've actually heard it called a NIC address before. Let's see. What's it called right there? The physical address. The physical address. Okay, so a MAC address, a physical address, a data link address, a layer 2 address, a burned in address. You need to know it by all these names. You have to know all those names. A hardware address. Because depending upon who you're talking to, they'll call it something different. Depending upon what kind of a test you're taking, it'll be called something different. If you're talking to a LAN tech, they'll probably call it a hardware address. If you're talking to a network tech, they'll probably call it a physical address or a data link address, right? So you have to know it by all these different names. A CAM address is another way it would be called, right? So Darren, what's one of the names it might be called?
Physical address.
Physical address. Todd, what's the name it might be called?
NIC address.
A NIC address. Jonah? Oscar? CAM address? Nope. What would it be called? Data link address. Tony, are there any left? Oh yeah, there's one more. Anyone? Oh, physical address. There's hardware address. Burned in address. That's the one I was looking for, right? So you want to know it by all these names. Want to know it by all these names. All right, so did we talk about encoding and decoding, and does everyone have an understanding of that? Right? So from the data link layer, right, that's when we change it from bits to whatever the media can understand, or vice versa. We take it off the light and we change it back to bits. Okay? Now the frame, what layer is the frame at? Layer 2, which is also called the data link layer. Okay? And what addressing is at the data link layer? MAC addressing. And it picks up a bunch of other stuff that we're going to talk about. So the frame will pick up other stuff. And encapsulation, do we understand encapsulation? Right? It's just that process of moving down and getting new information added to it. Or on the other side, being what? When I reopen it, de-encapsulated, right? De-encapsulated. Most common protocol suites. Okay. All right. So what are the 3 different delivery methods? Yeah, so unicast, multicast, and broadcast. Okay. So unicast is what, Paul? One-to-one. I'm sending a message to Paul. One-to-one. Right, one-to-one. Multicast.
A host sends a message to a group of hosts.
Yeah, so I'm sending a message to you people. Right? Multicast, many, one-to-many. One-to-many. And broadcast, Oscar. One-to-all. Sending a message to everybody. Right? I'm sending a broadcast email. Sending a pizza to everybody. Got it? Let's see. Okay. So let's talk about a default gateway. We mentioned a default gateway on the first day of class. So who can tell me what that was? well, let's not call it an access point because it might not be an access point, right? That's a more descriptive physical thing. So but you're on the right track, so keep going. It's the in or out point. Okay. Anyone else? Yeah, it's the exit and the entry point to a network, okay? So here's the other thing that's really important to understand. The default gateway is just a term. It's just a term for an interface, okay? So if I have a router at my house, and I have an interface, and this interface connects to my ISP, okay? And then let's say that I've got a Nest, right? The air conditioner, I've got a coffee pot, I have Netflix, you know, I've got whatever TVs, I have computers, okay? And all of these, you know, if Netflix wants to pull data on me, right? They want to see what I'm watching, right? So Netflix, they're out here. So in order for that information to get out, I have to have an interface, which is the exit and what? Entry point of my network. So a default gateway is just a term for the interface that gives the data the ability to go in and out. In and out. So here, that door, that would be like our interface. It's how I can get in, it's how I can get out. It's how other people could come in, and if they come in, they could go out. So a default gateway is just a term for an interface on a router. Okay, it's just a term for an interface on a router. Now, another important thing is if I don't have a default gateway, can anything get in or out? No. No, nothing can get in or out. If I close and lock that door, can someone come in? No. If I blow up that door, well, maybe someone could come in. But if all the rubble fell down, right, if it's broken, if that interface is broken, what if there's no IP address on that interface? Right. If you say drive to my house and I don't know what your address is, can I get there? Probably not very easily, right? I mean, you might be able to give me directions, right? And then it's a yellow house on the corner. But for the most part, it's a lot easier if I know what the address is. So a default gateway is an interface on a router, and it has to have an IP address, an active IP address. It has to have an active IP address. In the absence of that active IP address, nothing gets out. Nothing comes in. Remote communication does not work. Does local communication still work? Yeah, it probably does, right? As long as nothing's going bad. Okay. So everything can keep working at what layer? Okay, but I can't talk at layer 3. Can't talk at layer 3. Make sense? Okay. So standards and organizations, right? They talked about 802.1, 802.11, 802.3, the IEEE, ICANN, IANA. You got to know all those. I don't have any trick other than just memorize them, right? IEEE is the most common, so make sure you know that one. The Ethernet standards, 802.3, 802.11. What are the two most common protocol suites? Alan? Yes, they're open standard and standard. And then also, what are the two protocol suites we talked about? The OSI model and the TCP/IP model. They're protocol suites. Okay, but yeah, we have open standard. Now, you know, there's companies that create their own too, right? I mean, I don't know about any of those, but they can do that, and they can create their own protocols. Google has their own transport protocol. The two protocols, what are the two most common protocols at the transport layer? TCP and UDP. Well, Google, eBay, Amazon, they all have their own proprietary transport protocol. Hired some, you know, genius to make their own transport protocol. Okay. All right, so where does HTTP function? Yeah, layer 7 and 6, right? Layer 7 and 6. How about Ethernet? 2 and 1. Ethernet is a protocol and it functions at 2 and 1. IPv4? Network. IPv6? ICMP? Network. Network. Okay, let's see what else. DNS? I think it's application layer because it's really doing something at at a server, right? So domain name server, domain name service. Okay, so you want to know, and as we move through each layer, because again, today we're just talking about all the layers and how they relate to the OSI model. And then Wednesday, we're going to talk about the first layer, the physical layer, and we'll start moving through the OSI model. So on Wednesday, we're going to talk about the physical layer. So we'll be talking about like STP, twisted pair, untwisted pair, fiber optic, LC, SCs, multi-mode and single mode. We'll be talking about all of those things, speed, throughput, good put, things that relate to the media, okay? And then next week, we're going to do module 2, which is we're going to actually start connecting stuff. So it'll make more sense if we've already talked about the media. We've already talked about layer 1. That's one of the reasons we skip, and we'll come back to 2. Okay? Because then we'll know a little bit more about what a straight-through cable is, right? What a crossover cable is, which is what we'll be using next week. So it just makes a little bit more sense. And then after that, we move into layer 2, the data link layer. Okay, and the data link layer is divided into 2 sublayers. Okay, I'm not going to tell you what they are, but you tell me when we get to that. 2 sublayers. All right, so let's see. The PDUs. All right, so who can give me all 5 PDUs? Oscar? Okay, can you give them to me in order? I mean, I'll take them any way you got them, but up or down. But segment isn't the starter or the ender. Bits. Frame. Packet. Segment. Yes. Anyone? Data. Okay, so I remember it as don't send pets for beer. Why not? You could say do send pets for beer. Data, segment, frame. Don't send pets for beer. Data, segment, packet, frame, bits. Okay. Doesn't matter. Yep, doesn't matter. I remember it from top to bottom because I remember don't send pets for beer. Okay, what about the OSI model? Who can give me that? All of them?
Physical data link network,
Okay.
transport, session, presentation, application.
Yes. Always, let's see, all people seem to need data processing? All people seem to need data processing. That's a good way to remember it. So just so you know, I'll ask you these questions every day. So the sooner you memorize the OSI model, the TCP/IP model, and the PDUs, the better. All people seem to need data processing. Do send pets for beer. I don't really have one for the application the TCP/IP model. I remember a 10-man application transport internet network. A 10-man, ATIN. It's just the way I remember. There's probably a better one. Make up one that works for you. Okay, so what's segmentation?
Breaking the data into smaller chunks and then also through different paths
At what layer?
at the transport.
At the transport layer, right? I'm segmenting it, I'm chopping up that worm. It's going to get a number for tracking so that it can be reassembled at the other side. Now, it doesn't get a tracking number if I'm using UDP, just TCP, which we'll explain when we get to module 14, which is the transport layer. And multiplexing, who can tell me what multiplexing is? You want to give it another go there? Yeah, multiple transmissions on the same line at the same time. It can keep track of all those, right? It can keep track of all those. What address do we use at the data link layer? MAC addresses. What addresses do we use at the network layer? IP addresses. What do we see at the transport layer? Port numbers. It's the only layer that gives us a clue. Transport. Right? It's the only layer that gives us a clue, the transport layer. It's the only layer that gives us a clue, the transport layer. And all these protocols have different port numbers. HTTPS, HTTP, 80, DNS, DHCP, 67, 68, DNS, 53. They all have their own port number. They all have their own port number. Okay? Our device has a port number, a randomly generated port number. That's why when you look at this, it's just this like 55980630087. It's randomly generated. It's not a well-known port number. Like again, DHCP has a well-known port number. NTP has a well-known port number. Okay? They're assigned by IANA, I think. Okay? All right, let's take a break. It is 4:18. Let's come back at 4:25, and then we'll do decimal to binary. We did binary to decimal. We'll do decimal to binary. Okay? Let's take a break, come back at 4:25. All right. So it'll be handy to have your positional value chart out again, right? Until your brain really locks it in. So let's do it together, right? 2 to the 0 is 1. All right, so we just kind of need this all the time when we're figuring out binary to decimal, decimal to binary. Okay, and so we're just kind of reverse engineering it, right, when we're doing decimal to binary. Let's see, so I think of it kind of, there's a bunch of different ways you can do it, and maybe Jonah will show us your way. You have a good way. You have a good way. Okay, so let's say I want to figure out 128. Right? And I've got a pocket full of money. So I just kind of think to myself, well, you know, 128, if I've got a pocket full of money, do I have $128? I do. So I just turn it on, right? Because now I'm trying to go from decimal to binary. And so now if I have, and I subtract 128, have I used up my whole wad of money? Yeah, I've just used up everything. So everything else is just going to be what? They're just going to be turned off. They're just going to be turned off, right? So it's just going to be turned off. And let's see. So now I've got 249. So with this way, we kind of work from left to right. And I'm going to see if I can show how to do it. Do you want to show how to do it?
I can try.
Okay, let me do it like this, and then you show your way. Okay? All right. So 249, right? So first of all, will 128 go into 249? Could I buy something? I could, right? So that means my 128 is turned on. And if I subtract 128 from that, I've got 121 left. So could I still buy something for $64? I could, right? And 128 plus 64 equals 192. And remember, we're trying to get to 249. So we're just reverse engineering what we did. We're just reverse engineering what we did. Okay, so I've got $57 left after that. Can I buy something for $32? Yeah, I could, right? So now if we remember, when I've got 1, 1, and 1 turned on, that's what? 224. 220, and remember, I'm trying to get to 249, so I need to keep going, right? So again, if we just keep the reverse engineering, so if I subtract 32, that leaves me with 25. Can I buy something with for $16 if I have $25? I can. And again, we know that 1, 1, 1, 1 is what? 240, and we're trying to get to 249. Okay, so what about the 8? Would I have my 8 turned on? Yep, I'd have my 8 turned on, right? So now I'm at what? 248, but I need to be at 249. So is my 4, I can't buy anything for $4, right? I can't buy anything for $2 because all I have is 1 left. So my 1 is turned on. Okay? No, you did it the other way. Let's see. Let me think about it. Let me think about it. I know how. Okay. Let's do it this way a couple more times, and then I'm going to show you another way. Because sometimes if you see too many ways, it actually gets more confusing. So maybe we'll do it like this today, and then I'll get that easy. I think your way is easier.
I thought that was the exact same. That's how I've written down.
No, because that one did it the kind of like, yeah, it is kind of the same.
Binary decimal. The other form.
Oh, I thought it was this one.
The other one was like you multiply it by the powers of each single one.
I don't know. Now I don't know. I'm going to go back and look at that video. I actually thought that video was really good. Did I just go backwards? Oh, 240. How did it convert decimal? Okay, so we're going to do 105, right? So we're going to do 105. So if I wanted to buy something for $128, do I have enough money? So is it on or off? It's off, right? But if I wanted to buy something for $64, could I? Yes, so it's turned on. Now I have to subtract the 64 from the 105, right? And so I didn't do all the math there, but 64 You can also just add. So 64 and 32 is 96. 96, it's 96, right? And we're trying to get to 105. So if I'm at 96, how many more do I need to have? 9, right? We're just doing a process of elimination. So if I'm at 96, I'm trying to get to 105. Is my 8 on or off? It's on because I still need to have 9. 4 on or off? 2 on or off? Okay, and the 1 on. And also I have 105, which is odd or even? Odd. So I know that the 1 is going to be on. Okay. Let's see. So 25. 128 on or off? Off. 64 on or off? 32 on or off? Okay, so the first time that I've got something that I can use is the 16. So that one's turned on. Okay, now if I subtract 16 from 25, what do I have left? 9. So can I buy something for $8? I can, right? So 16 and 8 is 24. I'm trying to get to 25. What do I need to turn on next? The 1. Okay, just reverse engineering it. Sometimes these take a little bit longer until you get really good at binary to decimal. Once you're really good at binary to decimal, the decimal to binary gets easier. Okay, let's see, 86. So you all do 86. Okay, and then just write it down on your paper. And when you have the answer, just pop your hand up. Just write it down, don't call it out. And remember what we learned the easy form, for 80, right? Remember, you could look at your easy chart. So just write down the decimal to binary. Just pop your hand up when you have it. Okay. All right. So what was the easy pattern for 80?
0, 1, 0, 1.
Yeah, so if we learn that easy pattern, right, there I've got 80, and now I just need to come up with 6. So 8 on or off? 4 on or off? 2 on or off? 1 on or off? Okay, so again, that's where the easy patterns help us, right? Those easy patterns help us. So we did that one. Okay, so again, just the easy patterns, right? Okay, do this one.
What are we doing?
149.
What's the price?
149's the price. 149. We're not rounding. When you have it, just pop your hand up. Okay. All right, so 128, that's on, right? Now, if I were to add 128 and 64, that's too big. It's 192, so 64 is off, right? And then we know that the easy pattern of 128 and 32 would be 160, so that's too big. So this one would be off, right? But 128 plus 16 is 144, so that one would be on. That gets me a little bit closer, right? So if I'm at 144, I just need 5 more. So is my 8 on or off? That one's off. My 4, that one's on. 2, off, because I've got an odd number, right? And my 1, on. Just reverse engineer it, right? I don't have the Price is Right version. I should have it. Okay, so let's do a couple of Kahoots. Decimal to binary. Oh, we'll do this nice easy one. Can you activate this decimal to binary? And yeah, and check the time on it. The times have been all messed up. It's in week 2. I think it's in week 2.
So much stuff deactivated.
I know.
So this is
Well, that's all the class activities.
Tuesday, wrong class. Or is it?
No, I think that's the right class. Oh, maybe that was Leslie's class. All right, ready?
Decimal to binary.
Yes. 1 star. Excellent. It always feels good to get 10 out of 10. Good job, Darren. Outstanding, everybody. Okay, let's find another one. Let's do another one. Decimal. Oh, we'll do a 2-star. Decimal to, okay. Let's keep our brain on it. Can you find the other one too, Marcus? The 2-star one? Who am I missing? Oh, there we go. Okay. This one's probably a little faster, so don't stress, just do the best you can. Think about your easy patterns. So with these, so which two could we eliminate? As soon as I see the 197, which two can I eliminate? Right. So first of all, let's just look at this one because it ends in 0. That means that it would be an even number, and we're trying to get an odd number. Right? So that's one little clue and trick you can use. If you're trying to get an odd number, it's always going to have the 1 on. And then the other thing is, if we look at this one, same thing, it's a 0, but also the 128's not even turned on, right? And if I have a number bigger than 128, I'm always going to have that first positional value turned on. So just some little tricks you can start practicing to make these go quicker for you. So the 0, right, the first positional value is going to be on because it's an odd number. So again, this one red I can eliminate for a couple reasons. One is it's 240, it's an easy pattern. And then my first positional value, that's off, so it's going to be an even number. And let's see, what else? I can eliminate this one because 143, I have to have the 128 turned on. So I can eliminate that one too. Excellent. So this one is pretty easy to use a process of elimination too, right? Because if I'm trying to get 60, 1010 is what? 160, so too big. 1010, too big. 1010, too big. So even if I don't do the math, that's the only one left that could actually fit, so. Excellent. Who's in? Good job. Yeah, probably lots of 10 out of 10s. It just won't capture everybody. Good job, everybody. Not too bad, right? You just keep practicing. You'll get really fast at this. Yeah, you can work in the back. All right, we're going to do one more. We're going to do, let's see. Oh, we might do two more. All right, it's the OSI layer, maybe the TCP/IP layer too. OSI model layers. What's layer 8? User error. So if you remember, I said that this layer is broken into two sublayers. Yep, the data link layer. Six. layer at which a switch works. Layer 2. Layer 2, the data link layer. The network layer. Did you publish this one? Yeah. Okay, and perfect. Oops, where did it go? Wow. Good job. I'm impressed. I think 9 out of 11 and above is really good. That's good. All right, so let's see. Let's just refresh your modules. Again, we're in week number 2 under class activities. So we're doing the decimal to binary and the OSI. Was there another decimal to binary?
Not that I saw.
Okay, that's okay. We don't need to put them both in there. So again, just put a note in there that we did them in class. That way it gives you the little line on your calendar that we did it. Huh? Noon. So here's a website that Cisco has for practicing binary, and there's also some good apps that you can put on your phone and just play when you're just sitting around. Instead of playing Angry Birds, play binary games. Just get good at it, right? Just get good at it. All right, so I want you to bring this back on Wednesday. Okay. You hand those out. Just bring this back on Wednesday. Yes, keep that. All right, does anyone have any questions? So we're going to cover what layer on Wednesday? Thank you. Layer 1, which is physical layer, the media. What happens there? Encoding and decoding, yeah, right? We have to change it into a transmissible form, all right? And we will also cover hexadecimal and subnet masks, okay? So I will see everybody on Wednesday. Have a good day. Do a lot of homework, right? Front load. It should be this. It should be under class activities. It's more binary practice ideas. There's not an assignment, it's just a repository. So it's everything's under week 2 class activity Monday. So we did a bunch of stuff in class today. So just give me a little note that we did it so that you can get credit for it. Bye, Jonah. Okay. Feeling good about binary? Yes. All people seem to need data processing. So it's application, presentation, session, network, data link, processing is physical. All people seem to need data processing. There's a bunch of them. There's one about Paula Abdul, but I can never remember it. What's that?
Is that like a microphone for the
It
classroom?
is, yes.
So did you record today's?
I did. Well, assuming it worked. The reason I don't advertise it is because it's not always